Hey, it's John Broadwell, creator of the Serial Wombat open source project and a technical resource for hire at my company, Broadwell Consulting Incorporated. If you need help with an embedded systems or medical device project, give me a call. So right now we are very excited about we are about in the middle of our Kickstarter campaign. We are now fully funded, which is exciting. And we have still about 9 days left to go at this point. The Kickstarter closes at the end of April 2025 for those of you who want to be early adopters of the Serial Wombat 8B technology. And what that is custom firmware running on a CH32V003 microcontroller that essentially turns this microcontroller into an I2C controlled device that you can control from MicroPython or Arduino or whatever. This board that we're looking at right now is PCB0038, which we're calling the Serial Wombat 8B Buzz. It has 4 inductive buzzers on it, and it goes to pins 4, 5, 6, and 7 through these FETs and has flyback diodes so that we can generate 4 different tones at the same time. You heard that at the beginning of this video where we were playing Ode to Joy. That Arduino sketch is available in the Arduino library examples, and so you can see that there. Basically, this is very similar to the base Serial Wombat 8B board. You can see that I've kind of just extended the PCB out to add these additional parts. It's open source hardware, so I anticipate a lot of people will do that kind of operation. Pins 0, 1, 2, and 3 are not used by these, so you can use those for general purpose I/O, UART, ADC, any of the normal Serial Wombat type functions. There is a power LED for VDD. There is a separate power supply that feeds these guys. You want to provide up to 500 milliamps. If you're running all 4 of these at a 50% duty cycle, you could see 400 plus milliamps worth of power draw because these are inductive loads. There's a separate power LED that's available through this solder jumper to show if you have power on VN. As with the other Serial Wombat boards, you can set the I2C address. It starts at 0x60, but by closing other solder jumpers, you can add 8, 4, 2, or 1 in any combination to get 16 I2C addresses. As with the other boards where I have space to get it done, there's a QR code that leads directly to the Serial Wombat website and documentation that's specific to this board. In the future, this is going to be a certified open hardware project with the Open Source Hardware Association, at which point I will put the certification logo and the number in this area once that's been granted. So pretty straightforward, just Serial Wombat 8B that can output frequencies to these 4 chips, to these 4 buzzers. And this is available as the Serial Wombat 8B Buzz board on Kickstarter. Let's take a real quick look at the Arduino sketch and see how we got the Ode to Joy to play out. So in Arduino, if we go to File, Examples, Serial Wombat 8B, Buzz, and Buzz Ode to Joy, we get this sketch. And essentially we're going to instantiate a Serial Wombat chip. We're going to create 4 buzzers on 4, 5, 6, and 7. We're going to say the number of buzzers and the number of notes max that'll go into this array. Essentially, this is an array of 4 groups of notes. Each note has 2 entries, which is the frequency and the duration in terms of counts. Over here in Ode to Joy data, we've got a bunch of defines that define the frequency for various notes. We define, this is a 4/4 time song, and so we define a quarter note as 2 counts, an eighth note as 1 count, half note as 4 counts, and a dotted quarter note as 3 counts. And you can see basically here are each of the measures there's a total of 16 measures and split into 4 separate buzzers so that we stream out to each buzzer notes. When one note ends, we start the next note. And so you can see we come through here and we keep an array of 4 buzzers saying, hey, when does the current note end? And what entry are we on in that array? At the end of the array, we will have an entry that is 0, 0. and that indicates that you should stop reading the array at that point. So, there's a certain amount of space allocated, but if you've got a lot of eighth notes versus a lot of half notes, the length of each of the four outputs could vary. And you could put 0 in for the note, and that will act as a rest. It won't generate anything. So we come in here and we do a wire begin. We do a serial wombat begin and tell it to just find the serial wombat chip on the I2C bus. Then we initialize our 4 buzzers on pin 4, 5, 6, and 7. We go through and we start playing the first note of the song. And we say, okay, we're going to end, for each of the 4 buzzers, we're going to end that note on the current time plus the number of beats times the multiplier. So the multiplier in this case, 200 milliseconds per count. And so we could make the song play slower by making this 500. We can make it faster by making this 100. The note cutoff. We don't want to play the note for the entire duration. We want it to be like a piano where you plunk it and it comes back up. And so 25 milliseconds before the end of the note, we're going to stop playing the note so that you hear them distinctively instead of just a constantly changing tone. So we do that setup, then we come down into the loop, and we're just constantly iterating through each of the 4 buzzers, saying, is its note done yet? Is its note done yet? Is its note done yet? Or are we in the rest period between notes? And so we go through that over and over and over again. If the note has completed, then we go to the next note entry and we write the public data. The pins are in frequency mode. And so we write the new frequency to the serial wombat chip and we update when we're supposed to stop. And I should get rid of all this extra cruft down here. That was earlier code. And so you can see very, very minimal output for 4-note polyphony. So just for fun, let's recompile this thing and let's tell it, I only want you to use 1 buzzer, and we'll hear what that sounds like alone. And finally, if we set the time delay to 100, we get a much faster song. We're also going to reduce the note cutoff from 25 to 15. All right, so if you like this, hop on over to the Kickstarter and get one of the buzz boards or support the rest of our project. The rest of the Serial Wombat line is available at serialwombat.com. So browse around and find some interesting I/O expansion or smart coprocessor that helps you out with the project you want to do. So until we talk again, have fun and keep making stuff.